Hello everyone, this is Dr. Shivam Singh, Assistant Professor, ABES Engineering College, Ghaziabad, and today I'm going to deliver a lecture on amplitude modulation. So moving ahead, these are the contents that include modulation, need of modulation, modulation types, analog modulation, amplitude modulation, modulation index, frequency spectrum, advantages and disadvantages of AM, and applications of AM. So moving ahead. So first of all, what is modulation? So modulation is a process in which one of the characteristics parameter of a carrier signal, such as amplitude, frequency, and phase, can be varied according to the message signal amplitude variation. So this is the basic definition of modulation. And here we can see through the diagram also. If you can see, then we can see here baseband signal, that is a message signal that is going to be modulated with the help of a carrier signal. And here a product modulator we have used. We can see here a product modulator. Then after that modulator we are getting the modulated output. So that modulated output we can utilize at the output. Now moving to need of modulation. So these are the possible points that I have added, which can clearly justify the need of modulation. You can see suitable for long distance communication. Yes, because with the help of basically our message signals are a baseband signal, means containing low frequencies. So if you want to transmit your signal through a long distance, then it is required to utilize a carrier signal. So if we are targeting for long distance communication, then of course we need a carrier signal, or in short, we need modulation. Second is to reduce the height of antenna. Okay, so our message signals are low frequency signal. So if we calculate the height, then to transmit our message signals, we need a larger height of antenna. So to reduce or to overcome this issue, we need to multiply or superimpose high frequency carrier signals so that we can reduce the antenna height. Third one is multiple signal can be transmitted over a single channel. Yes, this is another advantage of modulation. And fourth is to eliminate the noises. Yes, for a low frequency signal, there are lots of noises in the channel. So to overcome this, we need to employ a carrier signal again, so that our low frequency containing signals become high frequency signals. And in this way, we can reduce noises also. Now, moving to modulation types. So basically two types of modulations. First one is analog modulation. Second one is digital modulation. So to be more specific, under analog modulation, we can see amplitude modulation, which we are focusing. Next one is frequency modulation, and another one is phase modulation. So these are the possible modulations that comes under analog modulation. Now moving to digital modulation, that is also a type of modulation. So it consists of amplitude shift keying, frequency shift keying, and phase shift keying. Now moving to analog modulation. So basically, we can see the definition also, that baseband signal is always analog for this type of modulation. Means we need to utilize sinusoidal signals, okay, for analog modulation. Now moving to types. So as I have discussed in the previous slide also, that is amplitude modulation, frequency modulation, and phase modulation. All these three are comes under analog modulation. Now moving ahead. So here we can see amplitude modulation. So definition, as I have discussed also, in amplitude modulation, the characteristic parameter of carrier signals, as I told, such as amplitude, phase, and frequency. Here we are focusing on amplitude. So the amplitude of a carrier signal varies as per the amplitude of the message signal. So here we can see a modulating signal, that is message signal. We need for modulation one message signal and also a carrier signal, that is denoted by C of t. And after modulation, as we have seen in our first slide, that we need a product modulator. So after a product modulator, at the output, we are getting this type of expression, that is amplitude modulated signal. and we are denoting as SAMT, that is amplitude modulated signal, that is equal to AC cos omega CT plus MT cos omega CT. Okay, so after manipulation, we are getting this type of output expression, or we can say the amplitude modulated wave. Now moving ahead, so amplitude modulation, we can see here also through the diagram. So here in first diagram, we have considered a message signal, sinusoidal signal. We can see that it is a low frequency signal. Now, if we want to transmit this message signal through a larger distance, then we need to consider a carrier signal containing high frequency. As we can see here, carrier signal contains high frequency. So now we are going to multiply, or we are going to superimpose these two signals, means message signal and carrier signal. So after multiplying with the help of a product modulator, we are getting the final modulated output, as we can see in the third figure. So this is the final amplitude modulated wave which we can transmit through the channel. Now we can see here modulation index. So modulation index is a very important parameter while analyzing the modulation process. So here we can see if we want to define the modulation index, then it is the ratio of the amplitude of message signal to the carrier signal. As we can see here, we have given also M equal to AM by AC. So in this way, we can define the modulation index. And modulation index also plays an important role while defining how much degree of a modulation takes place. So basically, it is ranging from 0 to 1. If M is 0, then very low modulation takes place. If M is very high, or we can say the maximum value of M is 1. If M is 1, then 100% modulation takes place. So in this way, we can analyze modulation index. Now we can see also different values are showing different type of modulation. Here we can see, as I told, if M equal to 1, then it is called a perfect modulation, means 100% modulation takes place. If M is less than 1, then it is said to be under modulation. In most of the cases, in most of the practical cases, we will see this type of modulation, that is under modulation, because M equal to 1 is the ideal case that no one can achieve. Only we can approach to this ideality. Now, if such case, that is M greater than 1, then it is called overmodulation. And in practicality, we try to avoid such type of cases, because if M is greater than 1, then we cannot extract our original message signal from a modulated signal. Now, moving ahead, here is the mathematical expression for amplitude modulated wave. Sorry. So here we can see, as I have seen in we have seen in previous slides also. So these are the possible expressions. I'm just holding. So you can see here. And the final expression, as you can notice at the end, AC cos omega CT plus ACMA by 2. So this is the possible expression for a amplitude modulated wave, in which here first term is the carrier term, and here second term, that is ACMA by 2 cos 2 pi FC plus FM into T. It is a USB, that is upper sideband, that denotes upper sideband of a amplitude modulated wave. While a next one, that is LSB, it denotes the lower sideband of a amplitude modulated wave. Here for upper sideband FC plus FM, and for lower sideband FC minus FM. So in this way, we can analyze the mathematical expression for a amplitude modulated wave. Now, moving to frequency spectrum of a AM wave, so then we can analyze the frequency spectrum by analyzing the upper sideband, lower sideband, and carrier signal. So we can better understand with the help of this diagram. Here we can see, as we have seen that there are three terms in amplitude modulated wave. The first one is carrier wave. We can see the carrier wave that exists at FC, that is carrier frequency. And talking about the upper sideband, as I have shown in previous slide, so that was FC plus FM, that denotes upper sideband, and lower sideband FC minus FM. So in this way, we can show the frequency spectrum of an amplitude modulated wave. And if someone is interested to calculate the bandwidth, then we can easily calculate the bandwidth by subtracting upper sideband from lower sideband. We can see also here bandwidth, That is FC plus FM minus FC minus of FM. So in this way, we can calculate the bandwidth, and we are getting the bandwidth which is equal to 2FM. Okay. Now, moving to the advantages of AM. So these are the possible advantages. Low cost, few components needed. It is simpler to implement. Yes, of course. Long distance communication. It is the major advantage of AM. And talking about the disadvantages of AM, so amplitude modulation is insufficient in terms of its power uses. Yes, the power wastage in amplitude modulation is more, and it requires high bandwidth. So yes, of course, it requires 2 of FM, means a double of the message signal frequency. So in this way, we can say that these are the possible disadvantages of AM. So moving forward, so these are the possible application of amplitude modulation, that are air band radio, broadcast transmission, quadrature amplitude modulation, and single sideband utilization. And these are the references which I have used to prepare the entire content. Thank you so much.